Patrick Cook here. Well, welcome to session number 25 of the Mastering Mandelbulb 3D Formula Tutorial Series. Now, we've always been talking about the alternate mode, or we've been in the alternate hybrid mode ever since we started this tutorial series. Now we're going to move on, okay? We're going to move into the interpolate. I'm going to clean up a little bit here. I'm going to reset and recalculate. All right, I'll tell you what. Let's just move this right back in the center here. Okay, recalculate. All right, good. All right. Remember now, the alternate hybrid mode is a process of layering. In the interpolate mode, we get a little bit more interesting, because in the interpolate mode, what's happening is it's an averaging. All right, kind of think in your head, alternate mode is layering, interpolate is averaging. Now the averaging it's different than the layering. It's different than the alternate mode. The alternate mode, we were simply layering multiple objects onto one another. Boom. And whatever we got on the screen was a process of all those pixels mixing together. Now with the interpolate mode, the object that's being created on the screen is actually a derivative of math. We don't need to talk about the math, but we just need to understand that it's not a simple layering, it's an averaging. Now here's what that means, all right? Let's assign two formulas. Now, in the interpolate mode, you can only assign two formulas. You can only two. All right, and keeping in mind that we're not in a layering situation, so we're mixing two formulas together. And here's what goes on. So let's get two formulas up here. Let's go to this formula slot number 2. I don't know, let's pick IQ Pine Tree. Let's calculate that and see what happens. Okay, not a whole lot happened, okay? Because there's another value that we need to pay attention to, and it's called weight. And here it is down here. All right? That's the weight of formula number 2 is 0. The weight of formula number 1 is 1. All that means is that in the averaging algorithm, in the deep down inside the code of the Mandelbulb3D application, what that means is that formula number 1, which happens to be integer power, is being given it's allowing all of its pixels to write. Formula number 2, which is IQ underscore Pine Tree, no pixels write. So we have an averaging, but only one of the Mandelbulb objects is basically making it through. Now let's just do this. Let's prove this by taking the weight of IQ Pine Tree, and I'm going to set that to 1. Which, if we go look at formula number 1 now, the weight was 1. So what I should have now is I should have an equal averaging of both of these Mandelbulb objects. They both mathematically mixed. All right, and let's see what I get. Okay. So here now, and this is not layering now, the math has determined that they're each going to get equal billing. All right, they're each going to get a weight which is similar or identical to the other. So what I have here is a precise mix of two different formulas that each had an average weight that's equal to the other. Let's just kind of prove what I just said. I'm going to say Let's go back over to IQ Pine Tree, and I'm going to give that a weight of 0.5. So it's only going to have half of a weight to the integer power. Let's see what it looks like. You see how the integer power object is more prominent now? Let's come over here and make our IQ Pine Tree 1/10 0.1 of 1 of the integer power. Let's run that. And as expected, we're seeing the integer power bulb is more prominent. All right, are you getting the sense for what this averaging does? Okay. Let's set the integer power to 0.1, and let's come over here and set the IQ Pine Tree to 1. Now that Mandelbulb object is going to look remarkably different because when I calculate it, it's going to be more prominently IQ Pine Tree. All right, calculate that. And a lot of my integer power bulb is lost. So that's IQ Pine Tree. All right, and if I set the weight down to 0 on the integer power with the weight of 1 here on IQ Pine Tree, basically integer power doesn't process at all. That is what IQ Pine Tree produces as a Mandelbulb object. Okay? So when it comes to the interpolate, you can interpolate two different formulas together. They have to be escape time. You can't mix an escape time. That's 3D, 3DA, 4D, 4A, and dIFS. You can't mix those together in interpolate. They don't, their math is entirely different, okay? You can mix and interpolate escape time, and you can mix and interpolate dIFS, but you can't mix escape time and dIFS together. All right. So understanding what the interpolate does, the interpolate hybrid mode, is entirely based upon understanding that you're averaging two formulas together and that you get to decide what the averaging ratio is going to be. All right, now in the minute or two that I have left in this session, let me just explain to you that this weight down here is not a percentage. It's not a percentage. It's not 1.1% versus 1%. It's not a. It's just a plain Jane everyday basic ratio. You know, 1 to 1 or 0.5 to 1 or whatever, and I'll prove it to you. Let's take this integer power. Let's set that to 1, and let's come over here and set the pine tree to 0.5 and execute that. All right. Now, I'm going to come over here and I'm going to set this weight, used to be 1, to 1,000. And I'm going to come over here, which used to be, yeah, okay, 1 to 1, right. Okay, now I'm going to set that to 1,000. And I should see no difference in that object, and I do not, proving that this is not a percentage. It's just simply a weight, a numerical value weight. Now, I'm going to do this for you. I'm going to put this to 1, integer power. IQ Pine Tree is 0.5. Okay, that's the object I get. Now I'm going to come over to integer power, and I'm going to set that to 1,000. And I'm going to come over to IQ Pine Tree and set that to 500, half the amount. The object doesn't change at all. I'm going to set this to 10,000. Okay, I was not, okay, I'm going to set integer power to 10,000, and I'm going to set integer power to 10,000. Okay, IQ Pine Tree to 5,000. Half the amount of integer power. Calculate. Again, it doesn't change. So, it's important to keep in mind that the weighting between these two formulas is just a very simple integer value. It's not a percentage, whereas 1 to 0.5 produces the exact same result as 10,000 to 5,000. Okay? I just wanted to make that point. All right, so let's end this session here. Join me in the next session. We'll continue this fun, and we'll take it from there. I'll see you there.